Hello everyone, myself Hans. Today we are going to solve the given problem based on straight lines. Here in the question, prove that the lines which meets the lines y is equal to mx and z is equal to c and y is equal to minus of mx and z is equal to minus of c, and the hyperbola is given xy is equal to c square which meets z is equal to 0 generates the surface. We have to prove that the lines intersecting the given surface and generates the given surface. Let's solve the problem. Given lines are y is equal to mx and z is equal to c, and the second line is given by y is equal to minus of mx and z is equal to minus of c. The given line we can also written as, that is, y minus of mx is equal to 0 and z minus of c is equal to 0, and the second line is written as y plus mx is equal to 0 and z plus c is equal to 0. Let this is, we have to write, let this is the equation 1, and we have to write any line of intersection of equation 1 is, first we have to write the first line of intersection, y minus of mx intersecting z minus c, written as, that is, y minus of mx plus k1 z minus of c is equal to 0. And second we have to write y plus mx is line intersecting z plus c, we can also written as, that is, y plus of mx plus of k2 z plus of c is equal to 0. This is the intersecting line equation, and from here we have to find the value of k1 and k2. From here we can find the value of k1 and k2. From here we have to find the value of k1, that is k1 into z minus of c, and y minus of mx is taken into right hand side, that is minus of y minus of mx, and from here k1 is equal to y minus of mx minus of y and plus of mx, that is mx minus of y upon z minus c. This is the value of k1, and from here we have to calculate the value of k2, that is k2 into z plus of c, and y plus of mx is taken into right hand side, that is minus of y plus of mx, and from here, that is k2 is equal to minus of y plus of mx upon z plus of c. This is the value of k1 and k2. We have to write here, that is, the value of k1 is mx minus of y upon z minus of c, and the value of k2 is minus of y plus of mx upon z plus c. This is the value of k1 and k2, and in the given equation, if the lines of intersecting, then the z is equal to 0 meets the surface. Further, the given intersecting lines meets at z is equal to 0, then we have to put z is equal to 0, then we have to put z is equal to 0 in the intersecting line equation. First we have to put in this equation, that is y minus of mx and from here plus of k1, in place of z we have to put 0, that is 0 minus of c is equal to 0, and from here that is y minus of mx minus of k1 c is equal to 0, and from here we have to find the value of x. Once again, then let this is equation 2, and from here the in the given above line we can also put the value of z is equal to 0, then y plus of mx plus k2, in place of z we have to put the value of z, that is 0 plus c is equal to 0, and y plus of mx and plus of k2c is equal to 0. Let this equation third, and from equation second and third we have to calculate the value of x and y. From equation second and third, calculate the value of x and y. First we have to add equation 2 and third, adding equation 2 and third, that is equation 2 is given by y minus of mx minus of k1c is equal to 0, and the equation third is given by y plus of mx plus of k2c is equal to 0. We have to add equation 2 and third. From here that is plus of mx and minus of mx is cancelled out, and plus of y and plus of y, it is 2y. 2y minus of k1c and plus of k2c is equal to 0. And from here that is 2y is equal to minus of k1c and plus of k2c is taken into right hand side, that is plus of k1c and minus of k2c, and from here we have to take a common c, that is k1 minus of k2, and y is equal to c by 2 k1 minus of k2. Further we have to solve using equation second and third. We can also calculate the value of x, that is subtracting equation 2 with third, that is equation 2 is written as y minus of mx minus of k1c is equal to 0, and the equation third is given by y plus of mx and plus of k2c is equal to 0. When we have to subtracting, changing the sign, first here is plus, that is minus, here is plus, this is also minus, this is plus, this is also minus, then plus minus, y to y is cancelled out, and the remaining is minus of mx and minus of mx, that is minus of 2mx, and from here that is minus of k1c and minus of k2c is equal to 0. Further we have to minus k1c and minus of k2c is taken into right hand side, that is minus of 2mx is equal to k1c plus of k2c, and from here we have to take common c, that is k1 plus k2, and from here we have to calculate the value of x, that is x is equal to c times of k1 plus k2 upon minus of 2m. This is the value of x. Further we have to put the value of x and y in the given hyperbola xy is equal to c square. Further putting the value of x and y in the given hyperbola, and the hyperbola is given by xy is equal to c square. We have to put the value of x and y, that is in place of x we have to put c by c times of k1 plus k2 upon, here is minus of 2m, into the value of y is here, that is c by 2, and k1 minus of k2 is equal to c square. Multiplied, that is c to c square, and here is c by 2 and here is c by minus of 2m, that is c square k1 plus k2 into k1 minus of k2 upon 2 into 2 is 4, that is minus of 4m is equal to c square, and from here c square to c square is cancelled out. Then further we have to multiply it with the 4m with 1, k1 plus k2 into k1 minus of k2 is equal to minus of 4m. Further we have to put the value of k1 and k2 in the above equation. Here we have to calculate earlier, the value of k1 is mx minus y upon z minus c, and the value of k2 is minus of y plus mx upon z plus c. We have to put the value. In place of k1 we have to put, that is mx minus of y upon z minus c. In place of k2, that is minus of y plus of mx upon z plus of c, into, again we have to put the value of k1, that is mx minus y upon z minus of c, and minus of k2 here, and here is also minus, that is minus minus is plus, that is y plus of mx upon z plus of c is equal to minus of 4m. Further we have to solve. We have to take the LCM. Taking LCM, that is z minus of c and z plus of c, and from here we have to mx minus y into z plus of c, and here is y plus of mx into z minus c. We have to take the LCM in second part, that is into multiply, that is z minus of c and z plus of c. Here is also, that is mx minus of y into z plus of c and plus of y plus of mx into z minus of c. Further we have to simplify. On multiplying with mx minus y with z plus c, that is mxz and minus of yz, mxz and minus of yz. Further we have to multiply c with mx minus y, that is plus of cmx and minus of cy, and here is minus, and taking curly bracket, again multiply z minus c with y plus mx, that is z multiplied with yz, that is yz plus mxz, and again minus c multiplied with y, that is minus of cy, minus of cy, and minus of c multiplied with mx, that is minus of cmx, upon here is z minus of c, z minus of c, and z plus of c. Further we have to calculate this bracket, that is multiplied and multiplying with z with mx minus of y, that is mx, we can use mxz minus of yz, mxz and minus of yz, again multiply c with mx minus y, that is plus of cmx, and multiplied c with minus of y, that is minus of cy. Again we have to multiply z minus c with y plus mx, that is yz, and plus of mxz, plus of mxz, again multiply minus of c with y plus mx, that is minus of cy, and minus of cmx, upon here is z minus of c and z plus of c is equal to is minus of 4m. From here, that is minus of cy plus of yz, and minus of yz is cancelled out, and plus of cmx and minus of cmx is also cancelled out. Further we have to solve, that is mxz minus of yz plus of cmx minus of cy and minus multiply with this bracket, that is minus of yz and minus of mxz and plus of cy and plus of cmx, and from here that in this bracket and the remaining here is mxz and mx, that is 2mxz and minus of cy and minus of cy, that is minus of 2cy, upon z minus c and z plus c. Here is also z minus of c and z plus c, that is we can also write, that is z minus of c and z plus c ka whole square 2 times, here is in the equal to, that is minus of 4m. Further we have to solve from here, that is minus of mxz and plus of mxz is cancelled out, and plus of cy and minus of cy is also cancelled out. Then the remaining is cmx and cmx, that is 2cmx and yz and minus of yz, that is minus of 2yz, and here is remaining, that is 2mxz and minus of 2cy upon z minus c and z plus c ka whole square cross multiplication with minus of 4m, that is minus of 4m into z minus of c and z plus of c ka whole square, and from left hand side taking common 2 from each bracket, that is taking 2 common, that is 2 from here and 2 from here, that is 2 to the 4, and the remaining is cmx minus of yz, and in the another bracket, that is mxz minus of cy is equal to minus of 4m and z minus of c and z plus of c का whole square we can also written in the form of that is z square minus c square का square. When we have two expanding z square minus c square, that is z plus of c and z minus of c का whole square. We get 1 second. Z minus of c, z plus of c. That is z minus of c का whole square and z plus of c का whole square. This is 2 times written in one bracket. Z minus of c का whole square and z plus of c का whole square. Further we have to write that is z square minus of c square, that is z minus of c and z plus of c. Further we have to, from here that is 4 to 4 is cancelled out and the remaining is that is cmx minus of yz and in another bracket that is mxz minus of cy, and from here that is minus of m is taken into left hand side, that is plus of m z square minus c square का whole square xy z minus of c and z plus of c is equal to 0. This is the required solution of the given problem. And in the given equation we can also change into, that is in the last plus of mc square minus z square written as L square, and we can also write in the form of that is cmx minus of yz into mxz minus of cy and plus of m, and we can also write in the form of that is c square minus of z square. Nothing to change. This is we have to prove cmx minus yz and mxz minus cy plus of m c square minus z square का whole square is equal to 0. This is the required solution of the given problem. Thank you class and thank you for watching.